lovely little formula at the top. You guys, some of you may have seen this, like if you're taking physics or anything like that. This formula is used for the path of an object. It's the object's height based on the time that it's in the air or doing whatever it's doing. So you'll see this formula, and I will give this to you if we have a test or quiz and you need it. But this is going to be the formula for the height of an object based on the time that it's in the air or doing whatever it's doing. So H is height in feet, T is time in seconds, and in this formula, V there, it's velocity, initial upward velocity. So velocity is really just a fancy word for the speed of the object. All right, and then you have this C that's in there. That C is the initial height of the object. And we're going to get into this with some specific examples today, obviously. But initial height of the object, if it's launched off the ground, the height would be 0. If it's launched like off of a table or something like that, then it might have a height of some kind that's not 0. So we might have a number plugged in for C, we might not. And then the only other thing I was going to ask you before we start doing this, does anybody know what the negative 16 in that formula is? It's always in the formula. Does anybody know what the negative 16 is representing? Yeah, okay. Do you know? It is. Yes, you're the first person to know that all day. Okay, perfect. Okay, so negative 16, and it's actually feet per second is what that represents. That you will always see that negative 16 in the formula. That is just the force of gravity. Specifically for this formula, it's in feet per second. There is another formula that looks super similar to this, but it has a negative 4.9 instead of a negative 16, and that's just in meters per second. We usually do the one that's feet per second. So that negative 16, that is actually the force of gravity on the object. So we're just going to do a couple problems, and we're going to plug them into that lovely formula there. All right, so this says I have a firework and it's shot up in the air with an initial velocity of 80 feet per second. So in that lovely little formula, the 80 feet per second, it's just your velocity. So we'll replace V with that when we write our equation here. And then instead of launching it off the ground, it says the firework is like sitting on like a table like this, like 3 feet off the ground. We're going to launch the firework. So the 3 is going to be your initial height. So in that formula, that's going to go in place of C. The negative 16 is the force of gravity, so that's part of the formula. So as you do this, the height of my firework is going to be negative 16 multiplied by my time squared. So it's going to be t squared. And then it's plus your initial velocity, which is 80, multiplied by the time. That t squared is what creates the quadratic here. And then plus your initial height, which is the 3-foot table in this question. Now, I'm just going to point this out to you guys. The way this is laid out, where you guys are used to seeing X is the time, and where you guys are used to seeing Y is the height. So whenever I have a point or anything like that for anything on this graph, it's very similar to just Y equals AX squared plus BX plus C. It's just using different letters to represent the height of the object and then the time that it's in the air. Okay, I'm going to use this little, sort of just like a blank graph. So I'm going to draw just like not to scale or anything, but a little path for the firework. So it starts at a 3-foot table, so just going to come a little bit above the origin. And then if you launch a firework or whatever, something in the air, it's going to go up, but eventually the force of gravity is going to drag that back down to the ground. So that would just be kind of like a general idea of what the path would look like. And I know it's going to be a parabola that turns upside down because of the negative 16. Well, I think it's like the little thing that it shoots out, and you know what I mean, like the little thing that, because eventually the debris is going to come back down to the ground. But you're right, it would explode at the top, yes. But the little thing that you shoot, it's marking the path of that. That's a really, really good point to make, actually. Anyway, what would you guys do to answer that first question? It says, what's the height of the firework after 2 seconds? Like, how would I figure out how high in the air it would be? Yeah. Exactly. Now, this is where I'd probably grab my calculator because the numbers are kind of big here. But all this means is the time is 2 seconds. So you're just going to plug in 2 for the time and find the corresponding height that goes with it. So it'd be negative 16 times 2 squared. Please don't, like sometimes people will plug the number in and they just forget to square that initial term. So don't forget to square the 2. And then it'd be plus 80 times just a plain 2 and then plus 3. Can anybody tell me if you did that on your calculator, like what should I get for my height of the firework? What'd you get? Yes, okay. Anytime you do any of these questions, if it starts with that negative 16 for the gravity, the height's going to be in feet, and the time is always going to be in seconds. So this will be 99 feet. All right, now, most of the questions today are going to ask you these next 2 problems underneath here. It says, in how many seconds will the firework reach its maximum height? And then what is the actual maximum height of the firework? Where would you have the maximum on that graph? On the parabola? Yeah, where on the parabola? The top, which is the, there you go. I knew that's what you meant. Okay, so it's just going to be the vertex. Any of these questions, maximum or minimum, they're just asking you for the vertex. Now, when you find, like, if you will, like quotation marks, the x-coordinate of the vertex, that's going to be the time it's going to take, bless you. And the y-coordinate, where you guys are used to finding that, will be the actual height of the firework. And I'm assuming that's where it would explode, I would hope, at the very top. So, let's see. How many seconds will the firework reach the maximum height? Let me pull this back down so you guys can see the formula again one more time. This is in standard form. If you remember this, you cannot see the vertex in standard form. And this is laid out the same way, it's just got h and t instead of x and y. So the deal is to find a vertex from standard form, I'm just going to remind you guys the little formula, the x-coordinate of the vertex is the negative b over 2a. So, and you guys, and I know I don't have it on the screen right now, your a value would be the negative 16, your b value would be the 80 from the formula we have for this question. So I want to make sure you guys don't forget this from when we talked about this a couple days ago. When you plug this in, opposite of b there would be negative 80. 2 is part of the formula. The a value is negative 16. You got to remember, I have to figure out what this product is on the bottom, or I just got to put parentheses around that on my calculator if I'm going to do that. All right, so do negative 80 and either figure out what that is. The bottom of that should be negative 32, or put parentheses around the 2 times negative 16. What should I get? And it's okay if it's not a nice plain number. What'd you get? 2.5. Okay, did anybody not get 2.5? Make sure you put parentheses around the bottom if you did not. So this would be 2.5. 2.5 what? This is seconds because you're finding time. So this is the time. So it's going to take 2.5 seconds. So basically, let me slide this down here just really quickly. All right, so basically on my graph here, like the x-coordinate, we would be, this is not to scale at all, it would be over 2.5. Now, what is the fireworks maximum height? How would I figure that out? You're going to plug it in, right? This is your vertex. So this is your x-coordinate. To get your corresponding y-coordinate, or in this case the height, you're just going to plug in whatever you got for your negative b over 2a. For this question, we got the 2.5. So you're going to grab your lovely formula. Your height at that 2.5 seconds, you're going to do negative 16 times 2.5. Please don't forget to square that. And then plus 80 times 2.5. And then plus that 3. That was the initial height of the table that we launched the firework off of. Can anybody tell me what the height, what'd you get? Close, close. What'd you get? I think it should be 103. Let me check. I bet money forgot to square the 2.5. So I got negative 16, 2.5. Don't forget to square it. And then plus 80 times 2.5 plus 3. Has to be 103. That would be your maximum height. Does anybody have any questions? Okay, now, right underneath this, when you find the maximum, or if you find the minimum, it's the same formula, that little negative b over 2a. You now know the vertex for that parabola is 2.5, 103. That would be the vertex, right? right underneath here, it just asks you to write the standard form we had at the top in vertex form. So does anybody know what the A value should be in vertex form? It's the same, it's -16. So if you have a standard form equation, just grab your exact same A value. We're gonna put that in front of some parentheses. Okay, I'm just using H and T instead of X and Y to match the equation here. So T, it's minus the X coordinate of the vertex. So the X coordinates here looks like positive 2.5. It looks like negative 2.5 when you guys put it into the formula. Close the parentheses, don't forget to square, that gives you the quadratic. And then the Y coordinate of your vertex, which is the 103, it's positive. So I'm just gonna add that to the side and then we're good. So once you find the vertex, you can do vertex form. The only other thing you need is the A value. And if you found a maximum or a minimum, then you found the vertex. Anybody have any question? All right, you're definitely going to want a calculator for this one. So this one has some weird coefficients here. So it says the cost C in dollars of fuel per week for Bob to operate his truck is given by this formula. So we've got C is for the cost, 0.004 V squared minus 0.48 V plus 142. V represents the average driving speed. I think they used V for like the velocity of the truck, if that makes sense, and that's going to be in miles per hour. The first question just says, what's Bob's weekly cost going to be if he drives an average of 70 miles an hour? Like, how would I figure out his cost if I know his average speed is 70 miles an hour? Plug it in. That's it. You're going to plug in 70. Now, just when you guys type this in, there's 2 zeros in front of that 4, so 0.004, and then plug in 70, don't forget to square, minus 0.48 times 70, and then plus 142. So see if you can figure out, this will be a cost for him. How much is it going to cost him if he averages 70 miles per hour? I think it should be a nice number. What'd you get? Should be 128. Anybody not get that? If you didn't, I will come look at your calculator. All right. Now, if you guys are looking at this lovely formula they gave us in the question, I just want you to think about this for a second. If I were to graph that, I'm not asking you to do that, but if I were to graph that, would that parabola be like a U shape or would it be upside down? How do I know? Exactly. This is a super tiny number, but that A value is, it doesn't matter how tiny it is, it's positive. It would be a really wide parabola because that's such a small A value, but it would turn up like that. So in this case, it's going to ask you to find the speed at which Bob should travel to minimize his fuel costs. This graph would have a minimum because the parabola would turn like that. So the minimum would be at the bottom. You can't have one, or you can't have min and max. It's one or the other. So the question we just did, let me pull this back down for a second. Like on this question, the way the parabola turned, this would be a maximum. So it made sense they were asking us for the maximum height. This question, the parabola would turn like this. So it makes sense that they're asking us for the minimum speed he should travel, and then we'll find out what that minimum cost should be. Maximum or minimum, doesn't matter. It's exactly the same formula. This is just negative b over 2a. B is just the coefficient of your plane variable. A is the coefficient of your variable squared. So for this question, my B value is negative 0.48. So in here, opposite of B would be positive 4.8. And then I'm just going to make sure I put parentheses around the bottom of this. 2a here would be 2 times the 0.004. So just when you type that in your calculator, just make sure you put parentheses around the bottom. That'll tell us the speed we should travel at. Can anybody tell me what I got? It should be a nice number. Did anybody get whatever 0.48 divided 2.004? What'd you get? Should be 60. Okay, good. Good. This is 60. This would be miles per hour. Now, that is the speed he should go. The minimum cost, all you're going to do to get the minimum cost is you're going to plug in the negative b over 2a. You're just finding if it ever asks you for maximum or minimum, it's asking you for the vertex. So it's going to be negative b over 2a, and then plug in negative b over 2a. So for this guy, you're going to plug in 60. So 0.004 times 60, don't forget to square it, minus 0.48 times 60, and I'm writing too big, plus 142. Did anybody get that? This one has a decimal with it. What'd you get? Yes, yes, yes. It should be 127.60 for the cost. Now, again, to write the vertex form, this is super quick. That's why there's not very much space down here at the bottom. It should just be his cost. Your A value is the same in both forms, so it's that 0.004. Then in parentheses, it's his speed minus the speed at the vertex, which is 60. That's squared to give us the quadratic. And then I'm going to put plus that cost. I'm just going to put 127.6. You don't need the 0 for the actual equation for the relationship there. Is anybody having a question at the moment? All right, on the back of the notes, I'm just gonna do this one problem with you at the top. So we'll skip example 3. So I'm gonna cross a problem off the homework as well, but I do want to go through this question because this asks some really good information about the graph. So maybe I cannot get this adjusted today. Okay, it says Bree hit a golf ball from the ground. Okay, it says the initial velocity of the golf ball is 80 feet per second, and Ms. Grody should have typed that formula for you here, but I'm just going to write, this is that formula with gravity that we talked about a little bit on the front. So I'm just going to write the general form so you guys can see it for the question. You don't have to copy it. You already have it on the front. All right, now, the force of gravity is going to work on this, and I know it's the -16 because it's in feet per second for the velocity, so it's going to be feet per second for the whole graph. Time is going to be seconds. H is going to be height here. So I'm going to sub in the 80 for the velocity here. So -16t squared plus 80t. What's my initial height for the golf ball? 0. So you could put plus 0, but I probably wouldn't. If she's hitting the ball off the ground, the initial height would just be 0. So I don't need anything added to the end of that. Okay, now I'm just going to sketch just a teeny tiny picture like I did on the front, just to kind of give you an idea. So this would start at the origin because I'm not hitting the ball off of something. It's just going to come right off the ground. So we're going to hit the ball. It's going to go up in the air. And again, the force of gravity is going to eventually, this is a terrible parabola, pretend that's drawn better. But eventually it would come back down to the ground. This is just a sketch. All right. As you guys do this, it says, how long will the golf ball take to reach its maximum height? Maximum or minimum is just asking you for the vertex. This is just going to be negative b over 2a. How long is the time? When I get to the vertex here, the time is set up to be the x coordinate. So it would just be time and then height. That's the format for any point that I'm going to have on this graph. So if I find this, I'm finding the time. So we actually did this, sorry, I used the same numbers I did on the front. So opposite of b would be -80 over 2a, which is 2 times -16. This should actually be 2.5 seconds again, like it was on the front, because it's got the same velocity as the question I had over there. All right, now maximum height's going to be different. So we're just going to plug this in. So -16 times 2.5, don't forget to square it, plus 80 times 2.5. How high is the golf ball going to go here? Should be a nice number. How high in the air? 100 feet. Okay. Anybody not getting 100? All right. So I'm just going to draw on this graph a little bit. This is absolutely not to scale in any way, shape, or form, so keep that in mind. Here would be my vertex, right? And that's where my maximum is at. And we have our axis of symmetry. This would be 2.5 seconds to get underneath that. And then the height, and you can see this is not drawn to scale at all. I'm just doing a sketch here, but the height of that would be 100. That's my vertex, right? Now, normally, if I would ask you for the domain of a parabola, which I am doing in this next question, we'd go, oh, negative infinity to infinity. If we got it attached to a situation, though, that might not exactly, negative infinity to infinity would work for the equation that I have for this if it wasn't attached to a situation. So if I'm talking about this specific situation for this golf ball, it says, what's a reasonable domain for this? So the domain here would be describing the time that this golf ball is being hit. What would you guys tell me a reasonable domain would be for this? Like, what makes sense for the possible times for this situation as you go from left to right on that graph? Do what? From what to 5? Yeah. Okay. Start out. I'm going to put brackets on both of these, right? I start out at time 0. We haven't hit the golf ball yet. When we hit the golf ball, that's right at the initial time. And then how'd you get to 5? You just made it up. Exactly, right. This axis is symmetry. This is symmetrical. So if this is 0 here, it takes you 2.5 to get to the top, take you 2.5 to get back down, so that should be crossing right at 5.
Doesn't matter what the mass of the golf ball is.
I think that formula accounts for that. I'd have to look that up. I'm not sure. I'm not sure about that. But that formula is supposed to work for the gravity on any object, so I'll look it up and see if that does make a difference. I don't know. Nobody's ever asked me that before, so we'll have to look that up. Just for the purposes of this example, we're not trying to get too technical. We're just doing a general axis of symmetry. But so just 0 to 5 for that. That's a really good question, though. Now, the question right underneath here says, what would be a reasonable range? So what would be my possible, from bottom to top, what would be my possible heights for the golf ball? What do you think? Yes, okay. So the lowest possible height rate is just the ground, so 0, and then the maximum height is 100. Okay, now the last question, and this is kind of tricky. So it says, what's the height of the golf ball after 1.5 seconds? So super easy, we're just going to plug in 1.5. So it'd be negative 16 times 1.5 squared plus 80 times 1.5. All right. Did anybody get, what is this? What'd you get? Should be 84. Okay, so this would be 84 feet. Okay. I should have spaced this out better, but this should be 84 feet. I'm just going to go back up to the parabola just really quickly. All right, now I'm just going to sketch this on here. So, again, this is not to scale in any way, shape, or form. But after 1.5 seconds, the height of the golf ball would be 84 feet. The question that's right next to that one we just looked at says, will the ball reach this height at another time? So if you're looking at the parabola, right, the path of the ball, we're going up, and then gravity's going to bring me back down. So will I touch 84 feet at another place on the graph? Okay, you guys are all shaking your head, yes. All right, so wouldn't it, like, we're going to hit 84 on the way up, but as the gravity pulls us back, we're going to come back down. We're going to hit 84 somewhere over here. How would I figure out how many seconds that would be, or can I figure that out? Are you going to add 1.5, or what are you going to add? Is it going to be at 3? If you guys are looking at, this is really tricky. How many seconds would it be? It's not 4, it's not 3 either. Would it? I know this is so weird. This would be at 3.5. I didn't do a good job drawing this, so that's my fault. But the distance between, not the distance, excuse me, between this vertex, where the axis of symmetry here, this would be 1 second, from 1.5 to 2.5. So its mirror image, which would be its reflection, I would just add 1 to the 2.5. It has to be the same distance from that axis of symmetry, so it would be 3.5 seconds. It's because 1.5 is 1 second away from 2.5. All right, so for this question, I'd say yes, and it would be 3.5 seconds, which is where it would hit that height on the way down. All right, we're going to skip that last example. Is anybody having a question? Okay, if you guys want to grab